Hello, Precalculus students, and welcome to another video lesson. You might notice things look a little different this time. I went to Best Buy and bought myself a $10 headset and microphone, so that way my voice can come through more clearly, I hope. And this will also work well if we do any video conferencing down the road to answer questions and go through problems. And I also, I'm using a different program that shows my picture in the corner here, which hopefully will make it seem more like you're in the classroom and you can see me talking from up in the front of the room. So anyways, hopefully you finish your 5.5 on law of sines and practice how to solve triangles with the law of sines. Now, if you cannot use the law of sines to solve a triangle, then we're going to use what's called the law of cosines, okay? And you might think the law of cosines is just like the law of sines, except with a cosine instead of sine, but actually it's not. It's a completely different formula, as you can see here. All right, so quick reminder, when did we use law of sines? Okay, we use law of sines when you have an angle and a side across of each other of the same letter. So to use law of sines, you have to either know angle A inside A, or angle B inside B, or angle C inside C. All right. Um, so the two ways we did that were if you know angle angle side or angle side side. Okay. If you know side angle side or three sides, that's when you have to use the law of cosines, because the law of cosines involves two sides and the other angle. So in other words, if you know side B and C and angle A, you use this version. If you know side A, side C, and angle B, you use this version. Or if you know side A, side B, and angle C, you use this version. So there's, once again, just like with law of sines, there's three different versions. Basically, it's the same rule though, okay? You just switch the position of the A, B, and the C. All right, so whatever side is out front, the same letter angle is at the end. And the other two sides are in the middle, here, here, and then here and here, okay? So there's three different versions, but it's really basically just one rule, just the A, B, and C are switched around. Okay, and before we begin, you might notice, hey, wait a minute, that looks like a Pythagorean theorem. A squared plus b squared equals c squared, right? Just take away that. And that is true. The Pythagorean theorem is actually just a specific case of the law of cosines, all right? Because if you have a right triangle, if you call this angle C is 90 degrees, right? This would be C, this would be A, and this would be B. All right, well, the cosine of 90, if you remember from your circle, cosine 90 is 0. So if you use this with a right triangle, then cosine 90 is 0. 0 times anything is 0. That whole thing becomes 0, and you're just left with a squared plus b squared equals c squared, or Pythagorean theorem. So anyways, you've been using the law of cosines every time you did the Pythagorean theorem. You just didn't know it. All right, so let's do an example, one of each. We're going to do two examples here in this lesson, side angle side or side side side. Okay, so let's start with the first example here. Suppose you know side A, side B, and angle C. So once again, we cannot use law of sines because we don't know an angle and a side across from each other. We know two sides and the third angle. All right, so if you want to try and draw the picture, you can. Okay, angle C is rather small. It's 20 degrees, so I'm going to call that C. Okay, and A is 11 and B is 5. Okay, so we'll say that is angle A, angle B, and that side C. So you know side, angle, side. Okay, well, there's only one thing we can find first, okay, and that is side C, right? Because I know angle C, I know sides A and B. All right, so I'm going to find side C first, all right, using the third version of the law of cosines. So C squared equals A squared plus B squared minus 2 times A times B times the cosine of 20 degrees, okay? And from here, you can just type all that in your calculator, okay? That's 121, that's 25, that's 10 times 11, which is 110, cosine of 20 degrees, okay? Now, I simplified these first, square that, multiply that, but you don't have to. You can just type all that in your graphing calculator all in one step, okay? And it turns out that that whole number on the right is about 42.634. You can do the calculations yourself and double check that. And that is c squared. So then you do the square root of both sides. And since it's a side of a triangle, I can ignore the negative answer. I just want the positive answer. And I get that side c is about 6.53. I get c is 6.53. Okay, so I found all three sides now, A, B, and C. I have two more angles to find, angle A and angle B. All right, now it doesn't matter which one you find next, but I am going to find angle A, and I'll talk after I'm done. I'll talk about why we're going to do that one next. Okay, so let's find angle A next. Okay, I'm going to use the law of cosines to find angle A. And now you might be saying, well, can't I use the law of sines, right? Because now I know angle C and side C. So I know two of those. So I could set up a ratio with law of sines to find A or B. That is true, but be careful. The law of sines does not always work to solve for an angle. There's some cases where it doesn't work. And after I'm done with this example, I'll go back and explain why. So um, we're going to use the law of cosines to find angle A. And since I want to find angle A, I'm going to use this version, okay? So I have A squared equals B squared plus C squared minus 2 times A times B times the cosine of angle A. All right, now I also want to do this because I want to practice the algebra here. Be very, very careful. There's with the order of operations when you're solving for A, okay? So we can square these. 11 squared is 121. 5 squared plus 6.53 squared is 67.641. 10 times 6.53 is 65.3 cosine of A. Okay. Now, this is where we have to be very careful, all right? Think of your order of operations. I have this minus this times cosine of A, right? PEMDAS says you always multiply before you subtract. So do not subtract these two numbers. You're not allowed to do that. You cannot subtract this minus this and then multiply, right? This is being multiplied and this is being subtracted. So algebraically, you want to get cosine A by itself. So you're going to subtract the 67.641 and you'll get 53.359 equals negative 65.3 cosine of A. Then we're going to divide by the negative 65.3. So cosine of A is going to be negative 53.359 divided by 65.3. Okay. Finally, to solve for A, I'm going to do the inverse cosine of both sides. So A is going to be the inverse cosine of this number right here, negative 53.359 divided by 65.3. Okay, and as a reminder, don't divide this and round. You don't ever want to round in the middle of a problem as best you can. Don't divide this and round it. Just keep this whole fraction, do the inverse cosine of this number, and then round at the very end, okay? And you get about 144.8 degrees for angle A with the law of cosines, 144.8 degrees. And then angle B, that one's easy. You just add angle A and angle B and angle A and angle C and subtract from 180, and you get that angle B is about 15.2 degrees. Okay, so let me go back for a moment. All right, if I tried to solve for angle A here with the law of sines, I would have got the wrong answer. And let's talk about why. Okay, remember when you're solving for an angle, you always have to do an inverse function, inverse sine, inverse cosine, right? Let me go to the side here, right? But for inverse sine, remember the range of that, the range is negative pi over 2 to positive pi over 2, okay? In degrees, that'd be negative 90 to 90. So what that's saying is when you do the inverse sine angle, you will only get an angle between negative 90 and 90. But look at A is bigger than 90, okay? So if I tried to solve for that, I would have gotten the wrong angle. I would have gotten an angle less than 90, not an angle bigger than 90, okay? Now, inverse cosine, the range of that is 0 to pi, okay? Or in degrees, 0 to 180, okay? So inverse cosine will work if the angle is obtuse. Remember, obtuse angles are bigger than 90. So if the angle is obtuse between 90 and 180, you must use the law of cosines to solve for it. You may never, ever, ever use the law of sines, okay? So I would write yourself a little note at the bottom, okay? Always use the law of cosines to find any angle which could be obtuse. Now, you don't know before you solve it whether or not it is obtuse, but if it could be obtuse, In other words, only one angle in a triangle can be obtuse, right? The largest angle. Okay. So anytime you're solving for the largest angle in a triangle, anytime you're solving for the largest angle in a triangle, always use the law of cosines to solve for it. Never use the law of sines, okay? Because it could give you a wrong answer. Okay, so that's be very, very careful. Remember that. It's an important thing to note. All right. So back to this. Now, what I could have done, because as you can see, the law of sines is easier to solve for than the law of cosines. After I solve for C, I know that angle A is the largest angle because it's across from the largest side. Angle A is across from 11. So I could have used law of sines to solve for angle B and gotten the correct answer because B is less than 90. And then I could have added B and C and subtract from 180 to get angle A. So I could have done that, all right? But sometimes you have to use law of cosines to solve for an angle. So I wanted to walk through these steps here to make sure everyone did the algebra correctly, okay? So just keep that in mind when you're doing these problems. All right, now let's look at example 2 on the back. This is a side triangle. So there's 3 sides, okay? So no angles. We have to find all 3 angles, all right? And you don't really have to draw the picture, but if you want to draw the picture, let's see. That would be 10, that would be 7, that would be 5. So this would be angle A, this would be angle B, this would be angle C. Okay. So first I have to solve for one of the angles. Now I cannot use law of sines here because to use law of sines, you have to know an angle aside from each other, across from each other. I have to use law of cosines, okay? Now, technically, it doesn't matter which angle I can start with. I can start with A, B, or C, but think back to what we just talked about. You have to use law of cosines to solve for the largest angle. So if you have to solve for any angle first with the law of cosines, always pick the largest one first. So one more time, if you're given 3 sides, solve for the largest angle first with the law of cosines. Then you're free to use law of sines to solve for the other 2 angles, okay? Because you cannot have more than one obtuse angle in a triangle. All right, so in this picture, the largest angle must be C because it's across from 10, the largest side, okay? So I'm going to find angle C first using the law of cosines, okay? So 10 squared equals 7 squared plus 5 squared minus 2 times 7 times 5 times the cosine of C. All right, and I'm going to do the steps kind of quickly here because you can, that's just arithmetic you can do on your own. 7 squared plus 5 squared is 74. That's going to be 70. Cosine of C. Okay. Once again, just be careful with the steps. Do your order of operations correctly. Subtract the 74, so you get 26 is negative 70 cosine C. Divide by negative 70, so cosine C is negative 26 over 70. So then C is going to be the inverse cosine of negative 26 over 70, which is 111.8. And again, please check all the calculations yourself on your own calculator. Don't just copy down my work. I want to make sure you know how to do it. Okay, now once I find angle C, then I can find angle A or angle B. And because I know A and B have to be less than 90, then I'm free to use the law of sines. Again, you could use the law of cosines if you want, but law of sines is easier, so most students prefer law of sines if possible. So I'm going to say sine of 111.8 over 10, so sine of C over C equals sine of A over 7. So law of sine just like we did in 5.5. And once again, cross multiply by 7, and then do the inverse sine. So A is going to be the inverse sine of 7 sine 111.8 over 10. So A is approximately 40.54 degrees. And then once you get those two, B is easy. Just add up A and C, subtract from 180, and you get B is 27.66 degrees. All right, so there are your 3 angles for that triangle. Okay, one more thing I want to note before we move on. In any triangle, if I give you 3 numbers, if I give you 3 sides, any 3 sides do not make a right triangle. Okay, let's go back to this picture. Suppose instead of 10, suppose that this side was 20. That side was 20. If I had 20 and 7 and 5, right? Picture, these 2 sides wouldn't touch, right? If I took 3 sticks, this was 20, this was 7, 5, these 2 sides wouldn't touch each other, right? Because if that was 12, they would just be a straight line, okay? But this 20 doesn't touch, so it doesn't make a triangle. So in order to make a triangle, the sum of any two sides has to be greater than the third side. Not greater than or equal to, greater than. So in order to make a triangle, the sum of any two sides must be greater than the third side. Okay. So assuming C is the longest side, it doesn't have to be, but whatever the longest side is, add the two shorter sides. Okay. If that is not true, there is no triangle. So once in a while, you'll be given three sides that do not make a triangle. So always check that first before you do any work. Always check to see if those three sides make a triangle. That saves yourself some time. Okay. Or let's say you didn't notice that and you were doing your algebra and you came down to cosine C and you did the inverse cosine. This number inside would be bigger than 1 or less than -1, and your calculator would give you an error. So if the calculator gives you an error when you solve for an angle, well, it could have meant that you did some algebra wrong, or it could have mean that it doesn't make a triangle. And there is one homework problem like that that does not make a triangle. So again, if you're given three sides, always check this first. Check that it makes a triangle. Okay. And then lastly, application problems. So once again, these are just read the problem, draw a triangle, and then use either law of sines or law of cosines to solve it. Okay. So this is a baseball diamond, which is really just a square, right? It's called a diamond, but it's a square on its side. All four sides are 90 feet apart from each other. Okay. And it says the front edge of pitcher's rubber is 60.5 feet from home plate. So this is 60.5 feet. Okay. How long from the pitcher's rubber to first base? Okay. Now, this is not a right triangle. You cannot assume that. I know it looks like it is, but it's not a right triangle. Okay. So you might say we don't know any angle. Well, we do know that there's symmetry here. We do know that this cuts that angle in half, that 90-degree angle in half. So that angle there is 45 degrees. That angle is 45. Okay. So I can use law of cosine saying d squared is 90 squared plus 60.5 squared minus 2 times 90 times 60.5 times the cosine of 45 degrees. Okay. And I'll let you do the arithmetic in your calculator, and you solve, and you get 63.7 feet. Okay, so you can see it's not exactly a right triangle, that this distance is a little larger than this distance. So the pitcher's mound is a little closer to home plate than it is to second base. It's not right in the middle. Okay, so that was law of cosines. All right, so now between the law of cosines and law of sines, you can solve for any triangle that can be solved, assuming you know three-piece information between the sides and the angles. All right, so your homework for 5.6 is more just solving triangles. Page 440, 2 through 10 even, and then 11 and 39. 39 is another application problem. It draws a picture in the book. Just answer the questions there. Okay, so for all of these, the first 6 problems, they're just solve the triangle. But be careful. There is one of these where a triangle is not possible. So like I said, always check that first. Okay, so when you get finished with those, please take a picture and submit them to me if you can, or send them to me in an email. Just type up the answers if you can't take a picture on a phone or a mobile or something. And after you get 5.6 done, then I've got a review sheet to give you covering 5.5 and 5.6 together. Okay, talk to everybody later.